Mr. Amwa, Mr. Amwa, go
Please,
ahead.
I can't hear you.
Ah, others said they can hear me. Why you cannot hear? Mr. Adam Salifu, can you hear me?
Yes, please, I can hear you.
Then, Madam
Ye-
Sairam,
Yes,
can you
sir,
hear
I
me?
can hear you.
Prince, is it Gerard? Can you also
Y-
hear me?
Yes, I can hear you.
Then please, Stephen, kindly check your sound. All right, so let's proceed. Now I said the LMS page is populated with all the materials that you need so far. And assignment that you are supposed to submit are also there. With the MISEM project, you are to work in groups, and then one person or the leader of the group is required to submit the assignment on your behalf. So the only thing you have to do, ensure that you design the front page with the school logo, the name, the course name, the course code, then the list of the group members are there. Then one person will submit on behalf of the group. Then you print one hard copy. When you are coming for the face-to-face, you will submit that copy for assessment. I need that one because sometimes we have challenge with the online. I don't want anybody, any group should be at disadvantage. So if you can access the soft copy you submitted, the hard copy will be followed. And after accessing the hard copy, I'll return it back to you so that you can see what we have done and those areas that are supposed to improve. Feedback will be provided and you can work on them. So that's the purpose for the soft copy and the hard copy submission. There are some of the assignments, they are individual assignments. For those that are indicated individual assignments, you have to work on them individually and submit on the LMS platform. Again, when coming, you bring a copy of that one also. So course rep, you receive all the assignments, separate the individual assignment from the group assignment project, and then you put them into one either envelope or container to be submitted. So we have two separate package, individual assignment submission and then the group assignment submission. So I'll expect two packages from you on your face-to-face meeting. I hope this is fine with all of you.
Yes, sir. But sir,
Oh,
please, the group,
yes.
please, will you be creating the group for us or?
No. Oh, for the group, you have to do it too. In
Oh,
consultation with your course rep, you know
okay.
yourselves. So I will not create the group. So I want you to do it of your own choice. But minimum members of 3. I think I indicated that maximum should be 5. I would prefer you work in three-member groups. Not 3 groups, so 3-member groups. So each group should contain at least 3 members, the maximum 5. So you should decide. Looking at your class size, you are not many. So I would prefer you work in groups of 3 members. Group of 3 members. That will be appropriate for me. I don't want situation. Some of you will be 10, some to be 11, 20 in a group. Some people will not work. So there will be one more, but I will update you when it is ready. All right. On this note, thank you for coming. All right. So now let's proceed with what we have. If no further concern. All right. Then this is coming. I missed snap. Can you see my screen?
Yes, sir.
Yes, sir.
Mine is missing from my end here. Coming. Let me select it. Okay, good. So with them, Our unit today, we are looking at the process management. The objectives that we have, if you have not jotted them down, please kindly do so. We'll be looking at the first part, which is define the process and explain process state, and then describe the process control block. Look at the process state diagram with explanation. Then finally, we'll look at the information contained in the process control block, PCB, which our lady of the day has already asked. Today, because I've joined you late, I'll come back to my message after we are finished. Let me try and finish the content first. So, as I've indicated, for those of you who have read through the lesson, you first have a knowledge about what you are coming to discuss. But if it's your first time, then let me inform you. What this topic is about is processes. Why do we talk about processes in operating system? And then what is process? From our previous lesson, we discussed a process as a program in execution. Now, for modern computers today, as we all know, they are able to handle multiple programs at a time, which is otherwise known as multitasking. So, for the computers to be able to do this multitasking, they have to be able to manage the activities that is going on in the computer. So, with the modern computers, because they are able to load multiple programs into memory and run them concurrently, it is important for us to talk about this process management and understand how the system is able to manage the various processes, how it controls the programs, start some, suspend others, and continue with those that have been suspended, and then also proceed to do more pressing tasks and then continue with other ones that may be required according to the system requirement. So the main idea here is for us to understand what is meant by process, how our processes manage, and how tasks are being performed to allow the system to carry out multitasking. So that is all this topic is about. You should remember, for these processes to run, allowing some to continue or suspend some and allow others to continue continue with others, there is a laid down principles, or we call them algorithms, that allow the moving in and out of these processes in order to enable the users to perform or achieve their tasks. And those principles are referred to as schedulers. So we refer them schedulers. So under the schedulers, they also have their underlying principles or methodology. And this is also considered as algorithm. So today, we'll talk about the processes and how they are managed and how they are created, moved, and then terminated. Then the next one will be how are they moving in and out of the system. Then our next meeting will consider what is the underlying principles of managing these processes. So, as I've defined, process is a program in execution. So, as we go through, you further understand this. Now, modern computers have this schedule from the starting to the finish. So when you have a computer program, you all know that program is a set of instructions that perform a specific task. Now, this set of instructions, if you put them together, they come as a program. But if you go down, they have what we call source code. Then inside the source code, we have the source code that performs specific tasks, some that comes together to perform specific tasks. So when a single line of code is initiated, there's something that is generated, and that thing is called a thread, or we say a thread is generated when a line of code is initiated. So when the thread is initiated, it moves to produce the process, and the process lead to a program, and inside the program, a task is performed. So in all this, process goes through a certain stages, and those stages that it goes through, what happened at each stage, putting them together is what we are referring to as process management. So I'll be taking you through. When a process is defined, it moves from one state to another. So we have 5 states which we'll be considering, 5 process states. First one is when the process is created, it's considered as process creation. Then after it has been created, it moves to a state called ready. Ready state, it is a state where the process waits for the CPU action or CPU's attention. Now, when you move from the CPU and the ready state, it leads to it enters into another state called running state. Now, the running state, it is a state where the process enters into the execution mode for a task to be performed. And now, when it moves from the execution mode, it goes to another mode called either exit or terminated. We can call it exit or terminated. Now, a process can also be moved from a running state to a state where it will be temporarily suspended for a particular task to be performed. And that state is called block state. Block state. So depending on whatever you are doing. So these are the 5 states that processes goes through. We'll look at them as we go along. So this is what I'm speaking to. Please, are you with me?
Yes, sir, we are here.
All right. So when you see these things in your slide, just understand that these are the various stages the process goes through. But as it is listed over here, they are not in order of reference. So you can see new, running, waiting, which is otherwise known as block, ready, and terminated. Over here, it is not in order. But if in the actual process management cycle, it goes through the order like this: from new to ready, from ready, it goes to running state, and from running, it may either move to terminated or it will go to waiting, where it will be waiting for the CPU attention to allow other processes to take place. So these are the explanations. Are we fine? Okay. One very important thing that you must know, that there is no way 2 processes can enter into running state at the same time. All that you need to understand is that it is only one process that can enter into running state at each instance. So whenever you are dealing with processes, this should be at the back of your mind. Next thing is the process state diagram. This diagram is very important, and all of you need to know how to draw it and explain. You don't need to draw this one. Is this part of the assignment that I ask you to do? Is the diagram part of it?
Yes.
Yes, sir.
Yes, sir. It's part.
And have you done it already?
Yes, sir.
I hope no one has produced this particular diagram.
So we have.
Has anyone produced this particular diagram exactly as it is?
Yeah, similar one.
No, I say exactly. Listen to the choice of words. As for you can have a similar diagrams. The most important thing is that the concept is the same. The diagram might differ, but the concept and explanation will be the same. So if you have produced any diagram which is the same as what I have here, without you referencing the source as my slide or the source of your external or indicating your external source, then that diagram has to be replaced in your document before you submit. If you have already submitted, please go back and pull it down. Still, you have a deadline, date not yet met. You can go and do it. But if you submit your work with the same diagram, I will not accept it. The reason is that some of you will not do any extra reading. You will use, because I've sent a slide to you. So you go and use the slide as your source of material to answer the question. If you do that, you will not help yourself. So I will not encourage you providing the same material to answer the question that you are supposed to do. I hope you agree with me. Hello?
Yes, sir. We
Yes,
are
sir.
here.
Some of you, I know you are all busy people, have married families, you are managing your home, your marriage, managing your job, managing your education, and then your business as well. Please, it's important you spend some time to do extra reading. Okay, so now this diagram, the explanation is very simple. If you look at the diagram critically, you realize that the diagram starts with the new, and that is the first state of the process state, that cycle. And you can see the arrows. Please be careful. Don't just draw them anyhow. Check the way the arrows are directed. They have a significance in the diagram. So from new, the process means that it's created. So from creation, it moved to a state called ready. What did we say ready state does? When the process at the ready state, what does it mean? You have read this last week, so please, let's discuss it. Hello? Do I mention names? Hey, Mr. Desmond Edu, can you hear me? Stephen, can you hear us now? Only Sarah is talking. All right, I assume you can all hear me. If you don't want to talk, I'll proceed. If you have questions, then you can ask. If you are not talking, means that you are all okay with the lesson. Or should I move to the next slide or next program? Maybe you are all fine with this particular one. Should I move to the next
No,
topic? Hello, should I move on to the next slide?
no, sir.
But why won't you respond to my I don't know whether you have.
Sir,
Yes, what's the problem?
Sir, we can hear you clearly,
Yes,
please.
Yes, if you can hear me, respond to my questions so that I know you are hearing me. It's an interactive class.
Okay,
Sir, we are with
Otherwise,
you. Let's
okay,
move
sir,
on,
we are
please.
sorry for that. We are sorry for that. Sorry, please.
no, because here I'm not seeing your face, you are not seeing me. So your response will let me know we are all together.
Okay, sir, we
okay,
understand.
sir.
Please.
All right, so the process state diagram is shown as it is on the slide. The process starts from new, it moves to ready state. From the ready state, it goes to running state. At the running state, two things occurred. Either a process will be executed, complete, and terminate, meaning that the process will leave the cycle. Then that ends that particular process. A new task or new job will be admitted into the ready state. Then it moves to running. After running, it also terminates. Now, there are instances whereby process can be in execution mode or at the running state. That process may not finish or terminate, but another process will arrive which will require. Hello, the one using PC, can you change your name to your full name? Otherwise, I will take you off from the class. Everybody log in with your full name or ID. PC, the one using the username PC. Either you change your username or we take you off from the class. Is the person changing or I take you off?
Sir, please, I'm changing it. I was using my phone, but right now I want to use my laptop, so I'll change it.
That's because if you are not talking, I don't know whether you are the right student I'm talking to or not. Because interactive class, the reason why it's there is for us to interact, but we are not talking. I don't know what's the problem. Okay, so now I'm getting to the last stage. When you get to the running state, a process which arrives in the ready state, waiting for CPU attention, will have execution time shorter than a process that is already in execution. When such instance happen, what the system will do is that in order to optimize and manage the processes, the one with the more running time, which is in the running state, can be removed and then bring it to a waiting state. Or it can be moved and bring it to ready state. If you see the diagram, there are two arrows that come from the ready. We have one arrow going to the running and then one arrow from the running state and coming back to the ready state. And over there, there is activity that takes place carried out by a process called dispatcher. And this dispatcher is the one responsible for moving a process in and out of the running state. When a process in the running state and it required more time than the normal, let's say it require more time. For instance, a process is running which need about 10 milliseconds to complete. Then a new task arrive at the ready state. And the question I asked ready state, we didn't answer, is that at the ready state, the process there wait for the CPU's attention. So when a new task arrive there and is having about 2 milliseconds task to be performed, the system need not to wait for 10 millisecond process to be done before 2 millisecond process will be allowed to perform. So quickly, the dispatcher will move the process with 10 milliseconds from the running state and move in 2 milliseconds process to finish execution, leave the state or leave the queue and allow the one with 10 milliseconds to come back and continue. Is the reason why we have two arrows pointing there, one in and one coming out. Please, are you with me?
Yes, sir.
Then,
Yes, sir, we
another
are
thing
with you, sir.
that happens here is that a process can be running can be in the running state, and another process will also arrive at the ready state, which requires less CPU time to execute. So instead of waiting for the long period, maybe this time is having about 40 milliseconds to complete. And there are tasks which are there with a shorter time to execute or shorter execution time. So what the process management system will do is that it will consider the process that is in execution, which is having about 40 milliseconds to complete, move it from the running state, because this time it has more time to finish, and then a lot of processes with a shorter time, it will move it from the running state. Instead of going to the ready state, it will go and block the time and space. So it will go to a state called waiting. And that state will wait for some time. And then after it has finished executing the other ones, then it will move in. Now, why does this waiting period or waiting time occur? There are some processes that require some basic hardware functionalities, or they request a basic input and output devices to function. But when it is in execution, and those basic devices are not available, the input and output devices are not available for them to carry on their task, then they have to move them out of the running state and bring them to the waiting state or a block state to wait for the availability of the I/O devices before it will continue. So when you look at the diagram, this is how it works, and that is the explanation to it. So the moment the device is available, then the process that have been moved to the waiting state or block state will now move to a ready state. Look at the arrow. It's moving to the ready state, and then from the ready state, it will now move to the running state for it to be executed. Now, no process move directly from waiting state back directly to the running state. Again, as I said earlier, only one process can be in a running state at a time. So for the process to be able to enter into the running state, it has to go through the ready state, get the CPU attention before it can be admitted into the running state. So that is why the diagram is drawn this way with the arrow. So in explanation to the diagram, this is what we are supposed to know and how we will be required to explain in case you are asked to do so. So even though I have not collected the assignment, if you have not provided this vivid explanation to the diagram, then I will encourage you to go back and work on it effectively before we submit. So on this note, I want to find out if there is any question on the diagram for the process state before we proceed to the next level. Any question?
No, sir.
Okay. Thank you for feedback. The next thing that we'll look at is a PCB, which have already been discussed. So, as I've explained earlier, and based on the question Madam Seram asked, I hope I've got the name right.
Yes, please.
Okay, so the PCB is a central repository where the process state information of the various processes are stored. Its main purpose is to contain those information, store them, and then release them in order to know or to run the various processes as they have been arranged in the system. Now, in the next slide or next unit, we'll be talking about how the processes are scheduled. How do they arrive, or when they arrive, how do they move in and out? That's what we'll be talking about in the next session about the process scheduling. But for now, for the processes to be able to move in and out of the process cycle, the PCB helps by keeping this process state information, so that if a process move from the, let's look at this. If a process move from the running state and then come back to a block state, come back to the ready state, and is going back to the running state, where does it start from? Does it need to start from the beginning? No. It has to make sure that it starts from where it ends before it starts. And then when it comes to the block state, when the process is moving from the block state or waiting state to the ready state and to access the running, it doesn't need to start from the beginning again. It just keep the information, provide it, and continue from there. So now, if you are to know how this thing works practically, you notice that some of you have been hibernating your machines. And anytime you hibernate your machine, what's happening is that the state of the machine, whatever you have opened, either in a browser, in application, or in a document, all those information will be suspended and they will be at the state where they are. when you resume your machine, I believe you have experienced it. You notice that those programs don't start from the beginning. So if you are IT person or professional who does a lot of systems management or administration, or who carry out programming, you believe that, or you know that administrators don't close their sessions or their browsers anyhow. If you want to sustain it and keep your machine safe, the best option is to hibernate the system. And when you come back, you resume and then you start from there. So if you have been doing this, what we are doing is exactly what we are trying to explain here. And that's how the process state diagram work. And that's what goes into process management. Are we fine?
Yes, sir.
Yes, sir, we are fine.
All right. Now, there are some basic components that are stored in the PCB. And these are the various things that you must know, and then know their functions or explanation. The first constituent of a PCB is process state. Every process I've already explained. Process state informations are kept, so you need to know the process state. You have a program counter. Counter determines the number of processes that are in the session. Then we have the CPU registers. Registers decide, they hold the process information, and they also decide which process need to enter into the CPU for execution. So that is the work of the registers. And we have the process scheduling information. How are the process scheduled? Those informations are also being handled here. So CPU scheduling information are there. The memory management information. Those memory have been allocated, and then those that have been deallocated, how are they managed? So the memory management information take care of those allocation and the deallocation of the processes. And if the process has been, a memory has been assigned to a particular process, and the process is no more in execution, what happens is that the memory management unit will now deallocate the memory and send it back to its MMU, the location for other process to have access to that particular memory that is available. Then we have accounting information. Accounting information also tell us the state and the number of processes that are executing concurrently and how the system account for them. So we talk about the accountability. That is what the accounting information provides. Then the IO status information is also the part that keeps the IO information in the system. You remember when you look at diagram, we have the IO event, or we have the IO or event waiting. Now, a signal sent to a computer to obstruct the normal movement of a or normal performance of a computer is always referred to as interrupt. And we have 3 types of interrupts. Can someone remind us about the types of interrupts we have in operating system, and then the purpose of the interrupt is part of your assignment? Salome, welcome. I hope you can hear me. Where the one using the PC? Class, who can tell us the types of interrupt that we have in operating system?
Sir, please, the graphic user
again.
interface. Is it correct?
Come again.
The graphic user interface.
Which one?
I'm not too sure. I was asking if it's correct.
So you are answering the question with question, right? Until say it out. I answered the question with question. I said a signal sent to a computer or CPU to interpret is referred to as interrupts. And we have 3 types of interrupts. We discussed it at the early part of the lesson. The day I met you face to face, discussing the class. And you have tried, Auntie, but it's not appropriate. What we are talking about is about the working environment. The operating system provides us with two main working environments: graphical user interface and then command line interface. I think that's what we're trying to talk about, right?
Yes, sir.
Yes, yeah, that's good. But that one is for the user, that is for the working environment. But when you talk about the interrupts, it is a signal that is sent to a computer to upset its normal operation. And then there was one question I asked: you should critically examine the importance of interrupt in a computer or in an operating system. I don't know if you have answered that one, or it was not part of your question.
No, please.
Okay. Then now, Mr. Adam, tell us what is an interrupt, what are the types of interrupt, and what are their significance in computer or operating system.
So
Who-
interrupting operating system are signal that alert the CPU to suspend
Okay.
current activities.
Okay, Mr. Adam Salifu, I like your answer. Where is the source? Reference your source. Yes.
So source like
Where
Where you are
source
reading
of
from?
I say, we are answering questions. So
is that
we are answering questions. So
yes, I know you are answering. So I'm saying that where is the source of your answer? The answer is correct. Perfect. 100% correct. But I just want the source.
there's no source.
Oh
Is
no,
it
there's a source.
Wikipedia or ChatGPT or what?
Are you doing methodology
No,
research?
sir.
You are
Yes, yes. We are doing research.
Methodology
Yes, we are
research,
doing it.
yes.
method.
In a research methodology, were you not told that you don't just pick someone's information and present it as if it's your own without properly citing and referencing the source?
Yes, yes,
In
it's true, sir.
academia, it's an offense to do that, too. Very big criminal offense. They can even demote you. So, Mr. Salifu, your answer is correct, but I want you to tell us the source.
The source is jigs for jigs.
Okay, thank you very much. That's a good answer. Can you repeat it for our friends, those who don't know?
Okay, sir.
Can you read? I know you were reading. That is why I was laughing. That where is your source? I know you. But it's good. So tell us, where is it coming from? Then you tell them the source.
So, okay, the internet interrupting the operating system are signals that alert the CPU to suspend current activities and handle immediate tasks.
Good. See, I'm very happy that you have gone further to read the other one. That's what I'm saying, that a signal, interrupt is a signal sent to the computer or the CPU to obstruct or to upset its normal operation. I hope you heard me explain that way, right?
Yes,
Yeah.
sir.
Yes. Then that is why you have given us the details. So now we have mentioned the source, so I'm very happy, which confirming what I've told you, right?
Yes, sir.
So what are the types of the interrupts now? If not, what do you think is the importance of this particular interrupt in the computing? Hello, top up group. I think this is the first time we are meeting, and this is your first time in the system, right? I want to encourage you. So most of you, for you to come and do top up, it means that you have some fundamental knowledge or foundational knowledge that have led you to this place. Please don't hold on to them. Bring them out. Let us discuss and shaping some of those ideas so that you can move on a very good and perspective of your course. But when you ask questions and you are holding on, you are not contributing, it may be that what you think you know might not be the appropriate one. It will also be that you don't know, but you don't want to make it known to us that you don't know so that we can explain. And I don't know which one to take. If you ask questions and you are quiet and you are not coming out, please note. it will not help both your studies and our delivery. So I will encourage that once we are having synchronous studies, let's discuss, make the lesson more interactive than the normal usual reading. Are you with me?
Yes, sir.
Yes, sir.
Yes. In the wisdom of the organizers of the program, if you want to do a distance, we could have put all the materials there, ask you to read, we will set questions for you to go and answer. But they want you to understand the program, not just to acquire certificates. I know most of you are already working. You only need the certificate to buttress and secure your job or for higher opportunities, which is good. So we need to make the class more engaging and interactive for you to have the best of your time so that you can have an impact, the course can have an impact in your career to shaping you for a better direction of your knowledge. So for me, I will need your engagement to make, because this operating system is a generic course. It cuts across every aspect of IT, computer science, information security, computer engineering. Wherever you go, you do operating system. So if you don't understand the course, you just do it as a raw or normal program, and you may not have the best out of the course. And it involves a lot of reading. So when we are explaining the essential parts, try and get the key ones, then you are good to go. You cannot memorize everything to go and write the examination. Please, are you with me?
Yes, please.
Yes, sir.
So the interrupt, we have 3 types.
Yes, sir.
Where are they? Go ahead, Adams.
So hardware interrupts.
Yes. Yes. Either you explain or go to the next one. Which one do we refer to as a hardware? Which type of interrupt do we refer to as a hardware? That is what I mean. Or you can go ahead and tell us the next type. If you cannot explain or just mention them, other people will help you to explain.
Hardware interrupt can be from like the keyboard or mic.
Who is talking? Is that Mr. Nyako?
Yes, sir.
Speak loud. So I
We
can
can't
hear
hear
you.
you, Nyako.
I said hardware interrupt
Yes.
can be from the keyboard, the mic, the
Okay, you see, Mr. Nyako, that's good. But you see, as the name implies, hardware interrupt. So you put it in a perspective or in the context of the name, that it is a type of interrupt that is given or that is caused by the hardware device or the I/O device. So when the signal is coming from the hardware part to the CPU and to alert the OS, then that means that that interrupt is known as what? Hardware interrupt. Good. What about the next one? We have 2 more.
So we have software interrupt.
Yes, software interrupt. How will you explain it? That's the type of signal sent by the software. So when the software sends a signal, remember the definition of a interrupt. Mr. Adam, can you take your definition again? Definition of an interrupt. Can you take it again? Please, time. All right, so he said a signal that is sent to the computer to obstruct or to change the direction or the performance of the system. So if the signal is coming from, the keyword is a signal that is sent. A signal sent. So when the signal is sent from the hardware, then it is known as what? Hardware interrupt. When it is sent from the software, then it's a software interrupt. And then when it is sent from the CPU, it is known as trap, T-R-A-P, trap interrupt. So not trampo, trap, T-R-A-P, trap interrupt. It's Trump that can send signal to go and attack some country. But here is trap, T-R-A-P. So these are the 3 types of interrupt that we have. Now, the next question is, what is the importance of this interrupt? What is the importance of this interrupt? Now, the interrupt help the functioning or the operation of the computer. Without the interrupt, a computer will continue to work, or a processor will continue to work on a particular process, whilst the other processes will be starving until it finishes that process. No other process can have access to the CPU. So in the way of managing the performance of the computer, to optimize the performance, interrupts is set up such a way that you are able to offset the normal functionality of the computer to attend to the more pressing needs of the system or the processes and continue. And that is exactly what happened during process management. Those processes that demand more attention or high attention of the CPU are allowed to access the CPU or enter into the running state, and then allow other ones without much attention to wait for the other ones to have their turn before they continue. So that is how it works. Are we fine?
Yes, please, sir.
Good.
Yes, sir.
So a process may be known to be at a new state, to be waiting, running, or to be halted or terminated. So when you go through, please take time and read through the slide. You see that all the components of the PCB has been briefly explained and what the role they play in the computing system. So that is about the process management. Any question? Okay. In order to help you to understand this topic, there are a few questions that have been set down there for you. So we have an example of this self-assessment question like this. It says a process is executed in parallel, multiple instructions at a time. Is it true or false? Hello? Am I here alone?
I think
No,
it's
sir.
four.
So it's false.
Why? Okay.
Because processes are executed in sequence.
Okay, so meaning that only one process that can enter into the running state at a time. I hope you remember I made this point at the beginning part of the lesson, right? So please, the rest, go and do it. Since you are not ready to communicate, I'll leave the rest for you to go and then do it on your own. I don't know whether you are familiar with your own self or because I've not been meeting you regularly, so you don't want to talk in the class. But if I meet you
So we
once,
are with you.
oh, but it's only you that are making me feel that somebody is with me. The rest, I'm not seeing that. I'm not feeling their presence. Adams too, Mr. Salifu.
Yeah.
Yes,
Yes, sir.
with your references and then your something, it make the class active. So thank you very much, the two of you. I'm happy to announce to you that you have earned yourself 2 marks each for being part of the class.
Thank you, sir.
Thank you.
So keep the record. When at the end of the semester, you submit it for verification. If you are not able to justify it, then the marks will be nullified. So keep the record, state the reason why the marks have been awarded, the date and the time, preferably. Keep the date, keep the time, keep the reason for the award of the marks. Then you keep the marks yourself. So you may be providing a table format in Excel. This day, this mark was awarded to me because of this. To next time, you provide the next thing. So if you're not able to justify it, the marks will be nullified. All right, so that is about the first one. Now the second one, we have what we call process scheduling. So let's quickly look at the process scheduling. I've shared this material last week. You all have it over there?
Yes, sir.
Yes, we have it here.
Okay, and then it's also on the LMS platform, so you can get it over there. Let me look for my. In fact, because I've traveled outside Accra, I carry some small digital device. That's what I'm using. So I'm struggling to get some of the things. Let me look for the other one. If anyone have it, the person can share with me. Let me explain. So give me a minute to get it access on the screen. As for technology, it comes with its own advantages and disadvantages. All right. Can you see my screen?
Yes, sir, we can see.
Okay, so we have 20 minutes. Let me see how I can finish this one. Process scheduling. Now that we have looked at process management, that we understood that process management involves the activities that goes on, how processes are created, the states that they move through, and how and why they are able to go in and out. What exactly is behind the swapping of the processes from one state to another? What does this particular movement of the processes into the running state of the CPU and out of the running state of the CPU, those activities that goes in, the principles behind is what we are referring to as schedulers or scheduling. So we have schedulers that handle the scheduling of the processes, and there are 3 types of them. We have first scheduler known as job scheduler. Then we also have another one called a CPU scheduler. And then we have another one called the medium scheduler, or you can put it this way: long-term scheduler, short-term scheduler, and medium-term scheduler. These are the 3 types of schedulers, and they follow a certain order or pattern to do that. And that is what we are coming to look at in the scheduling unit, what scheduling unit is. And then next time, as I said earlier, we'll be looking at the algorithm behind. There's that algorithm that does the movement. So for now, let's move on to this. So we said by definition, process scheduling is the activity of the process manager that handles the removal of the process that goes into the running process from the CPU and the installations of other processes on the basis of a particular strategy. And the strategy here is what I'm referring to as an algorithm. The algorithm I will be talking about. That will be done next week. So since we all know, for modern computers can handle multiple tasks, multiple processes can occur, and multi-programming operating systems are capable of handling this. They allow more than one process to be loaded into the executable memory at time and then reloaded a process shared in the CPU. Now, look at this. There's something we call time multiplexing. When you talk about multiplexing in data, have you done data communication? Data communication and networking. Hello?
No, sir.
Yes, sir.
Hello, sir. No, sir.
Hey, but how did you arrive here? It's a level 200 course, so you might have done it in one of your previous courses that you did for either your diploma level. So not here, not in this school, but before you arrive, before you are admitted. So cast your mind back to data communication and networking. Now, when you talk of multiplexing involves the process where multiple signals are transmitted through a single channel, and at a point, those multiple signals are also splitted into their respective channels to perform different tasks. Example, you may be transmitting voice or sound. You also be transmitting multimedia content like video, And then also you may be transmitting something like data, and you also transmit text. Now, text and data do not move together, or voice, they don't move together. They all move through different channels because there are different types of signals, and they must have their various channels through which they'll transmit. But for convenience sake, you can decide to combine all the signals and pass through one channel. And what happens is that channel has to be encapsulated so that all the signals will have their respective path and move, even though they are passing through one channel, but they will not mess up. They'll have their encapsulated channels and move through. And when they get to their destination, where they are supposed to be split, they'll be splitted into their various channels. So if someone needs data, you have the data through the data channel. If somebody needs voice, you get a voice signal through the voice channel. And when someone needs video or multimedia content, it also goes through the multimedia content. Now, that process of combining multiple channels through a single channel, multiple signals through a single channel, and then split it into various channels is what we refer to as multiplexing. So you can have multiplexing and then deep multiplexing. So when you come to the operating system also, it is able to handle multiple tasks and then manage them such a way that each task has their own CPU time. That is execution time with the CPU. So even though the CPU is one, but it is able to handle multiple tasks at the same time to carry out the activities. And those multiple tasks are being performed based on a process that is being executed. So the ability of the operating system to manage these processes to allow them to have access to the CPU and carry out their tasks at a given time is what we are referring to as multiplexing. That we have a time multiplexing. So with the scheduling algorithm or the schedulers, they are able to position or arrange the processes so that they move in and out of the CPU at their respective time, while their time is due or they are needed to have access to the CPU. So that is what happened during the process scheduling. Okay, any question? Okay, if no question, then let's move on. All right, so process scheduling queue. There are 3 different queue that we'll look at over here. I want to explain to you. I don't know how best I can let you understand it here, but please, we are all already in the online business, so try and understand. So when you come here, look at it, said the OS maintain a separate queue for each of the processes states and PCB of all processes in the same execution state are placed in the same queue. So when you look at this, when the state of the process is changed, each PCB is also unlinked from the current queue and then move to its new state queue. That is why I was telling you about the this multiplexing, how they are able to carry out multiple tasks at the same time. But they go through, even though one CPU, but is able to handle all the tasks. So now, the process scheduling does this by using these 3 main queue that we'll be talking about. First one is called job queue, and the second one is the ready queue. Then the third one is the device queue. This way, they are able to explain or manage the various tasks. Now, one may ask, what is a job queue? Now, a job queue simply means that, or the duty of a job queue, it is a queue that handles all the processes that is in the system. So when your computer is on, any task that needs to be executed is loaded into the main memory. Then they will follow the queue. Now, when they are in it, does not mean that all of them have access to the CPU at the same time. What matters here is that when a particular one needs to be executed, that will enter into the CPU based on the time that is required, then to get executed. After that, another one move, and the schedulers will be moving them in and out based on the required time that they need in the CPU. So the ready queue, at this particular state, this is the queue that keeps set of all processes residing in the main memory. Remember, for multitasking, all processes are loaded into memory and they run concurrently, but the processes are selected based on demands. So how they arrive in the queue, that is how they will be executed based on the algorithm that is being used. Then when we have the device queue, if you remember previous diagram, we talk about the IO event. When a process required the services of a device and the device is not available, that process will be moved to the waiting state or the block state, waiting for the presence of the device for it to operate with. So that is what happened here. So device queue, that's the processes which are blocked due to unavailability of an IO device constitutes this queue. So all of them will form a queue waiting for the availability of the IO queue before they proceed. So that is about the process scheduling queue. And this is represented in a diagram like this. And this summarizes the entire thing that I was trying to describe for you. So if you can see from the diagram, can you all see the diagram?
Yes, sir.
Okay, so you see
Yes.
that we have the job queue, we have the ready queue there, we have the CPU, then we have the exit points, then we have the IO waiting queue also over here. So these queue have various significant role that they play in terms of the process management. Please don't forget, there are 4 slides under this unit. We have the first one, process management, process scheduling, and then we have the scheduling algorithms, and then multi-threading. They all fall under one unit. So don't take the lessons in isolation. What we just finished on the other slide, this is the continuation. So this is how they work in the system. So when the jobs arrive, the first place they go is the job queue. In the job queue, the schedulers now decide which job have the highest CPU access time, which one needed the CPU time most. So it will be decided by the algorithm that is being used. Then the job will move from the job queue to the ready queue. Again, in the ready queue, it is the only place a job can access the CPU. So when you are in the ready queue, that means that the job is waiting for CPU's attention. Please, are you with me?
Yes,
Yes,
please.
sir.
Good. So from the job queue, now it moves to the CPU. When it gets to the CPU, if the job in the CPU does not require much time, it will be executed, then it will be left to leave the queue. Once it exits the queue, means that that task has been completed. Then another one will be scheduled. Then it will also enter the ready queue. When it gets to the CPU and another job arrives at the ready queue, in that instant, if the one in the ready queue requires less time to execute, what happens is that the schedulers will move the task that is in the job queue, that is in the CPU, and then allow the new one that have arrived with a less time to execute to enter. After it finishes, then you can continue. So moving it out, you see the dotted line from the top. They have to move from the top to come and join the ready queue again and wait for the next 10 for it to go. Now, when the job also arrives and it requires that you need to get some IO device, maybe input device or output device to function, and those devices are not available, then they move it from the CPU and go and join the IO waiting queue, waiting for the availability of the IO device. The moment the IO device arrives, then it will now move to the ready queue and be scheduled to have access to the CPU time. It can go in and execute. So this is how processes are managed, and then scheduling are done to allow them to move in and out of your system. Okay. Any question? Yeah. All right. Similar diagram. We can have a different diagram to explain the same thing. Now, this diagram also follows the same process. We have the ready queue from the job queue. Now, under the ready queue, there are other sub activities that can happen. So different queue have been rearranged so that the job can be classified. There are some tasks that have a sub-task that can be performed. So they all arrive over there. When it is done, they leave the queue for it to be executed. So when you look through the diagram properly from above, you realize that a new process always put in the queue. Then it will move to the ready queue until it is selected for execution. And once it is allocated to the CPU, it starts executing until complete, then it move out from the queue. Are you fine?
Yes, sir.
Yes, please.
Yes, sir.
Okay, good. So please, you can take time, read about the scheduling queue and what happened with the sub processes and so on. Then you'll be good to go. Now, we have two states that we normally consider. A process may be either in the running state or non-running state. If the process is in the running state, that means that it's in the CPU. If it's not in the running state, it means that it is not in the CPU for execution. So that is about that one also. So if you talk about the process state, two process state models, this is what we have. Either you are in running state or you are in non-running state. Then we have this further divided into activities for us to carry out our schedule. For this thing should be done, the three main schedulers that are responsible for moving in and out of the tasks. Aside the queue that we have, how do the processes move in and out? These are the strategies or the algorithm behind the schedule, the movement of the processes in and out of the CPU. We call them schedulers. So as I mentioned earlier, we have long-term schedulers, short-term schedulers, and the medium-term schedulers. So depending on the job, how long the job will stay in the CPU, how many times, or like what is the required time for the job to be done. Or for instance, some of you can go to work and you classify your job. Oh, maybe you have 4 things to be done. Yes, you divide them based on how the intensity of the job that is involved. So the schedulers help to schedule the tasks as they arrive in the queue. So the long term means that those that have a long time to execute will take care of it. Those that need the shortest time will be taken care of by the short-term scheduler. And those who need the medium time for execution will also be handled by the short-term scheduler. And this is how they are represented in the diagrammatic form. Can you see the slide?
Yes, we can see.
Okay, good. So see, at the left side, you see the long-term scheduling. All the jobs that comes. For instance, maybe a job have arrived and needed maybe 45 minutes to execute. You can't send that 45 minutes task into the CPU, whilst there are other ones that needed 2 minutes, 3 minutes, 5 minutes. So if you have 45, 35, 42, all those long-term jobs will be scheduled in a different queue. So the long-term scheduler will take care of it. And those that needed a short-term, medium-term to execute, the moment they come, you require maybe a range of time to put into that medium term. So they come in here. So you see, ready queue is also at the middle here. Then we have the processor, and then we have the exit end. So if the jobs that need to be carried out have a shortest time to access the CPU, they will be rescheduled. So you have the medium-term scheduler handling the medium-term jobs, while you have the short-term scheduler also handling the short-term job, and then the long-term schedulers also handling the short-term schedulers. So that is how the schedulers are classified. Please, are we fine?
Yes, sir, we are cool.
Thank God. I like your opinion. So now, when you look at the diagram, it gives you a summary to this. So when you have time, please take your time and read the rest.
Hello.
The key things is what you need over here.
Sir.
Any question? Yes.
Yeah, please, I have a question. I don't know if you already explained it. Is it like, for instance, the job is supposed to spend like 45 minutes or 1 hour, and then it's in a ready queue. So another job comes, which is,
Okay.
let's say, and then this one, the first one, when it comes back to the ready queue.
Your line is breaking. You know, can you get close to your mic?
Okay. So what I was saying is that if the first one, which was 45 minutes, was
Yes.
moved to the waiting stage or queue,
Okay.
and it comes back again to the ready queue after the other one, the short ones have been executed. Will it start from where it ended, or it will start all over?
Oh, I think I've explained it as you said.
Okay.
That is the purpose. Auntie Sayram, can you help us answer this question? Is she there or she's gone? Hello? Madam Sayram. All right. Officer, what will happen is the PCB is responsible for keeping the process state information of all
Hello,
processes. Where were you?
Please, my network is on and off.
Oh, tell them they should tell your family not to hold your network. Oh, you need it now for action. Okay. So, do you want to answer the question or I should go ahead?
Please go ahead.
But did you hear the question?
No.
Okay. So, Mr. Prince, as I was saying, is it Prince Kwao? I want to pronounce the name well.
Yes, sir.
Okay. So what will happen is that once the process has been swapped, the process of moving it out is called swapping. Once it has been swapped at any state, the PCB, that's the process control block, will keep the state at which the process was before moving. So in the next round, when it is coming back to resume, it doesn't start from the beginning. It starts from where it ends. That is why we went through the process state information and the purpose of the process state PCB. So it keep the track of that particular process and know where it ended before being swapped. And then when it's coming back, there's no need for it to start. Our computer will be repeating one task over and over and over. They suspend it. They continue. Then I also use the process of hibernating our computers. When you hibernate a computer, even when you open a browser or you open an application, wherever you were working before you hibernate it, when you resume, it starts from that place. So that is how the schedulers handles it. Are you fine?
Yes, sir, I'm fine. Thank you.
Okay, thank you too. All right, so please, that is all that we have today. So the various schedulers are here. Another name for medium-term scheduler is called swapping. I just use the word swapping. So please spend time and read, and then you see. Then the long-term scheduler, another name for it is job scheduler. That's the another name we use for long-term. Then we have CPU scheduler. Another name for short-term scheduler is called CPU scheduler. So when you go through, you have this. So the summary of all that we have done is here. And then we have the three schedulers summarized here with the various names and then the terms that we use. So when you look at the comparison, we see that the long-term scheduler, it is also known as job scheduler, and the short-term scheduler is also known as CPU scheduler, and the medium-term scheduler is known as process swapping scheduler. So if you go through, you see the comparison in all the schedulers that you talk about. What you just need to know is that scheduling, it is the process of moving processes in and out of the CPU time or running state. And there's something we call context switching. After my time is up. Context switching. The context switching is moving a set of processes that are not in use to an external memory like your hard disk. And then when they are required, then they move them from the hard disk to the main memory again for access. So in our future studies, we'll be looking at the various type of swapping context. Page, you come to paging, you have demand paging and so on. So context switching, just know that is a process whereby processes that are not in execution are moved from the main memory to the external memory, and when they are required, they are moved back into the main memory. There's a diagram that explains that. Let me just give you that one, then I'll be out of here. Now, can you all see this diagram?
Yes, please.
Yes, we have process 1, process P1. It's in the, look at the top. We have the CPU and we have the main memory. The dotted lines are known as the memory, and then the CPU is there. So when the process is being moved from the memory, it goes to the CPU. So when the CPU is executing, see process 1 is being executed. At a point, it saves, the process state saves the information, and then it moves out. Then it allows, look at process 2. Process 2 that was previously out will now be restored. Then the process 1 will also go out, while process 2 come back to take over the CPU. Now, after the execution is done, or maybe it perform up to a point, it will also be suspended. Then process 2 will also be swapped out again, and then process 1 will come back. So if you see the diagram, that is how it's explained over here. So in the context of functioning in the operating system, there are some processes which may not be in use at a particular time. What happens is the hard disk also act as they act like a memory. So they create an external memory where the processes will be moved, and then when they are required, they move from there and come to the main memory. So that is about the process context switching. So when you read through, you get that one. And then the context switching, when it's also being switched, it just behaves like how the processes are being switched. So all the information will be kept. The counter, the scheduling information, just as the one we have in the PCB, will keep the information and then make sure they resume from where they ended. Thank you very much for this. On this note, I want to end here and give you this question to go and ponder over it. I remember mentioning it or answering it in the lecture. We said critically examine the importance of interrupts. Critically examine the importance of interrupts. And you can all write a note or you can answer this question on your own, right? Hello.
Hello,
sir.
sir. Yes, sir.
Okay, thank you very much. On this note, we have been able to cover what process management is, and then we also look at process schedulers. Our next lecture, when we meet, we'll talk about the process scheduling algorithms, and then we'll also look at the multi-threading of process scheduling. What is multi-threading operating system? Already we have talked about it. So in the process scheduling algorithm, it involves some mathematics. It is the mathematics that does the work. How do the process come out? What time should they wait, and then what time should another one go through? So there are about 6 process schedulers. We'll look at them and see. Some uses different approach, and then we'll look at how each of them works. All of them don't adapt one method. They have different approaches. That's what we are going to talk about in our next lesson. I want to encourage all of you, please kindly read through before we meet so that you can ask and inform questions, and then we can have an informed decision in the class. At the end of this, I want to end it here. Sorry, I've taken part of your time. I sincerely apologize for it. But for the sake of my message, I want you to go home and think about this. He said, what greater love has one does that one have to die for somebody? So one lay down his life for his friend. I don't know. We just finished spending Easter. I don't know how many of you have gone through the process, but Christ has done the needful. I pray that all of us will learn the sacrificial work Christ has done, and then we can replicate it to our friends, our colleagues, so that at the end of the day, the purpose of Easter will be fulfilled in our life. This one inform sacrifice, commitment, and then transformation. May this one be our keyword as we go through the week. Thank you for coming. Take care and stay safe. Bye-bye for now.
Bye.
All right.
Oh no.